keep everything organized when we're going over the problems. Try to label it so that if you're looking at the Kahoot video later, you'll be able to know what problem we're working on. All right, but we're not there yet. We're just working on this homework practice set. And remember, I don't have the same version number as you. I'm lucky to have a student version here. But my teacher resources don't always have the same page number, okay? So just mentioning it again, if you were confused because I'm not giving the page number, the only thing you need to look for is practice. There's others that are called scaffolding practice. There's some that are called examples. But practice in each section, right? Each section always has 10 problems. And I don't care if it goes to the next page. I don't care if it's 5 pages long. I'm not caring about the pages. I'm just telling you, hey, you got to do the workbook 1, 2, 2, numbers 1 through 9, 1 through 10. It's always this, right? And if you're confused, you're like, well, how do I find section 1, 1, 2? Well, then think of it just as page numbers. It's always down here, right? So guys, this is something that I know some people don't want to make mistakes, but this is really clear and straightforward because all the other sections that aren't practice don't have 10 problems. So you're just looking for the page that has 10 problems every single time in the math book and in the workbook, okay? So let's look at some 7, 8, 9 here. All right. Okay, so let's go ahead and do our process. We've been doing the process every time. So this is workbook 1, 2, 2, number 7. Okay. Now, label everything today, because then when you go to the video, you'll know where you're coming from here. Okay, so we have the workbook to start. First, we just read it, then we're going to do some bullet points. All right. A temperature outside is dropping at a rate of 1.5 degrees each hour. It is raining, and the weather station predicts a changeover from rain to sleet when the temperature reaches 32 degrees or below. Okay. Currently, the temperature is 53 degrees Fahrenheit, and the time is 8:30 a.m. When do you predict the changeover to sleet will occur? This is tricky. Okay, so now we're going to read through it. When I just read that, oh, Jessica's got it. Yeah. Good. Good, Jessica, you got it. Let's look at though and read it and put some bullet points. So a temperature outside is dropping at a rate of 1.5 degrees an hour. So it's dropping. It drops negative 1.5 degrees per hour. And you can just write it out. You can write it out like that. You don't have to make it all specific math terminology yet. You're just trying to understand it. So it's raining, and the weather station predicts a changeover. So it's going to change from rain to sleet. So sleet is kind of like halfway between rain and snow. Sleet is like frozen rain. It falls a little faster. So sleet is kind of like rain that's starting to freeze. And it freezes at 32 degrees because that's when water freezes. So let's see. If it's 32 degrees or below. So when we're going to have sleet, right? When, look, 32 degrees, right? 32 degrees or lower. So it could be equal to 32 and it could be less than 32, right? Because if it's 10 degrees Fahrenheit, that's really cold. It's going to be frozen. You're going to have snow at that point. So if it's at 32, it becomes sleet. So the rain becomes sleet when it's less than or equal to 32 degrees. All right, so we got that bit. And actually, this helped us because we saw that right here. You could see these words right here, 32 degrees or below. So we know it could be 32 degrees or it could be below that. Okay, so now current is equal to 53 degrees Fahrenheit. The time is currently it's 8:30 a.m. When do you predict the changeover to sleet will occur? So what time does sleet occur? All right. So everybody jot something similar to that. We're going to try to put it all together now. And I think it looks trickier than it actually is. Okay. So Can anybody in the chat, especially if you're still waiting? Okay, Haley, looks like you're getting it. What is the hard part about this? Because I don't really care if it happens in 5 hours or 10 hours. What's the last thing we're going to have to do? Especially if you have the answer, try to tell me, what is the last thing we're going to do? Right. What else? All right, Sienna, you got it. Okay. So it's not just a matter of how many hours later. Remember the question asked at the very end? When do you predict the changeover to sleep will occur? This is what makes it a little bit tricky because it says 8 a.m., 8:30 a.m. So not only are we trying to find how many hours later, we're going to be using that 8:30 a.m. as our starting point and add that number of hours to it. Okay. So I hope we all have this written down now. Anybody need a couple more seconds? All right. So remember the goal, the total, the budget, whatever you're constrained by or shooting for always goes on the right side. So here we're trying to see when, so this is kind of like the goal, is when does the temperature get to 32 degrees? And here's the temperature. Okay. Now remember, in the problem, it actually said it changes from rain to sleet when it's 32 degrees or below. So this right here, I know also gives me the hint that we're looking for the temperature on the left side to be equal to 32 or less than 32. Okay. So when we have that, we look at that and what did the temperature start at? Let's see. Currently, it's 53 degrees. All right, so we did this. Check them off as you go. And I just did, currently it's 53 degrees. Okay. Now it's going to drop. It's going to drop 1.5 hours or degrees per hour. So all I have to do is minus 1.5, but that would only be in 1 hour. I need to put an X here to show that I could have 2 hours, 3 hours, 4 hours, 5 hours. And I would plug it in there because we're dropping at 1.5 degree an hour. 10 hours, it's going to go down, right? 15 degrees. But we probably won't need that much because I look here. Well, we'll see. We might need that. Okay, so let's go ahead and solve for this. I'm just going to rewrite it. Okay, line down your inequalities. And let's go ahead and do what we know to do. We know we got to get rid of this 53, so let's subtract it. Okay. Now the rule is going to come up. The rule for inequalities is going to come up, and I'll review that again. This negates out 53. We end up with negative 1.5x is less than or equal to, what is that? That's 19, 21, 21 negative. Take the sign of the larger, negative. Find the difference between it. If I add 21 to 32, I get 53. So we're good. We're down to almost the last step. Now this last step, remember, and write this if this is, you're not sure what I'm going to say here. So remember, if you multiply or divide by a negative, you're going to switch direction of inequality. Okay. So for instance, a less than or equal would switch to become greater than or equal to. Sorry, you couldn't see that, could you? All right, so it looks like that's going to happen because what are we going to do here? We're going to go in and we're going to divide by 1.5 on both sides. X is, negative 1.5. Forgot about this negative. That's why I was giving you the prep and the remember here. Since we divided by a negative 1.5, instead of it being less than or equal to, now it becomes greater than or equal to. All right. And what does that equal? Divided by 1.5, 3, 7, 14? I think so. I don't know for sure this morning. Divided by 1.5. I'm right. 14 hours. Okay. We're almost done. I'll put this as a cloud because I don't want you to think it's done. It's just going to be on our mind because, we did all the other parts here. We know we started at 8:30. I think these two right here, we kind of combine the idea and say, well, what time is it going to start to sleep? So if I look at that, we need 14 hours after 8:30 a.m. So what I'd like to do is think, well, if I'm at 8:30 a.m., if I go to 8:30 p.m., if I go to 8:30 p.m., right, that's 12 hours. So going from 8:30 a.m. to 8:30 p.m. is 12 hours. We need 2 more hours, so we're going to go plus 2 hours and get our 10:30 p.m. Sleep occurs. That is the final answer. Okay, so I think that what I boxed here was the hardest part because it gave you some kind of time. Okay, so kind of keep piece of information where you're like, well, that's not going to be inputted into the equation. We're going to then find the number of hours and then go back to that. Okay, so I don't think you're going to have one like this for Monday. It won't quite be like this. Okay, thumbs up, sideways, down for whoever called on that. Is it sideways still for that? What do you say? Sideways still. Okay. Is it because of this? Thumbs up if it's because of the time kind of threw you off a little bit. Yeah. Okay, that's an extra element, and it is an extra step. That's more of a challenge type problem. But I have another type of problem involved, and I'll let you know the types when we go over the Kahoot. I'll give you a hint on what we're going to do. All right. So let's go ahead and go to 8. All right. All right, first I'm just going to read it. A recreation center holds a soccer game every Saturday morning for older teens. The group agreed that there should be at least 5 players on each team. Okay. One team started out with 17 players. After an hour of playing, 3 players started leaving every 5 minutes. That sucks. Okay, at most, for how long can the team keep playing, right? So you got to at least have 5 players on the team. You start with 11 and people start dropping out. Maybe they get tired or whatnot. Okay, nice. Okay, so I'll see if that works out here. Let's write down what we know. All right, number 8, workbook. All right, let's see. Saturday morning, older teens, that doesn't mean anything. That's insignificant. The group agreed that there should be at least 5 players on each team. So each team, at least 5 players. So it could be greater than, I'm just going to write it first. Each team, at least 5 players. I'm going to do it exactly how I did it last time or before. Okay, one team started out with 17 players. So start with 17 players. Okay, after an hour of playing, okay, 3 players start leaving every 5 minutes. Oh, this is good. So after 1 hour, right? So that's going to be key. After 1 hour, then 3 players. So we're going to have minus 3 players because it's leave every 5 minutes. If you thought you had the answer, double check. Did you keep this in mind? That they start leaving after 1 hour. Okay. So let's see. All right. Let's see. At most, for how long can the team keep playing? Okay. So I'm going to actually assume here that we're going to keep in mind that it's after 1 hour that all this happens. Okay. So let's look at this. Got it. Yeah, we'll see. We're gonna have to. These have like little bits to it that make it slightly harder. Okay, But let's do one thing at a time. We know that the total, the goal, the limit, the budget goes on the left side. So we have to have at least 5 players. At least 5 players. Okay? So because that is the total, I'm going to put that on the right. And if I have at least 5 players, here's the end, right? And here's during the game. And we're talking about how many players stay or go. During the game, there has to be greater than or equal to 5 players. Okay? If it was switched, then that would be saying that during the game, there has to be less than or equal to 5 players. But we know during the game, there has to be greater than or equal to 5 players. So I'm going to put it like that. Check that off. Okay. Now, we start with 17 players. 17 players. That's pretty easy. After 1 hour, then 3 players leave every 5 minutes. Okay. So let's think about that. 3 players leave every 5 minutes. Okay. So we know that if they're leaving, we know that it's going to be subtracting, right? Now, how can I say it? Because the units right now, right? The units are players. There's 17 players. We're losing some other number of players. Then we're ending up with our limit here. We have to have at least 5 players, right? So I'm just going to keep in mind that I'm subtracting 3 players, and this is where it's tricky, and I won't have this on the quiz, but I like this challenge problem. 3 times x, and x, right? X are 5-minute increments. That might not be spelled correct. But an increment is, right, after 5 minutes, right, if x is equal to 1, then we have 1 5-minute interval or increment. You could say interval as well. So you have 1 5-minute interval. If x is equal to 2, then we'd have 2 5-minute intervals. If x is equal to 5, we'd have 5 5-minute intervals. We're going to have to do a little bit of work at the end. Okay, but let's just take this now and we'll solve it. We'll deal with x as we go. So it seems like all these problems like this is like the last problem where we're going to use this information at the end after we find out how many of these 5-minute increments we'll have before we lose the number of players we need. So let's go ahead and subtract 17. Okay. See ya. Negative 3x is greater than or equal to. Keep the negative and take the difference because they're different. All right. Now, the last step here, remember our rule about switching the inequalities, because I'm going to divide by a negative 3. When I do that, that cancels, but I just have to remember the one rule. X then, this changes, it switches. It switches to be less than or equal to 4. Okay? So now we know x is less than or equal to 4. Okay? But here's the thing with this. 4 is how many of these increments, these intervals, these 5-minute intervals, how many we had to have, right? So if this was, after 1 hour, 5 players leave every minute, then we would know that we had 4 minutes before we lost our team. But here's the thing. It says every 5 minutes, you're going to lose 3 players. So x is, if we had units here for x, it'd be x 5-minute intervals. This one's tricky. It's a little hard for me to even explain it, but we know x is less than or equal to 4, so we're just going to interpret this. X is less than or equal to 4 5-minute, I'm going to use intervals because you're going to see that more, right? Because it's not just 4 minutes, 4 whatever. It's, okay, after the first hour, everyone's getting tired, right? After the first hour. So then, after this is 5 minutes, right? 5 minutes, you're going to minus 3. After another 5 minutes, you're going to minus 3. And what we found with this our 4 there is telling us really that we have 4 of these increments, right? Especially for this problem, it might be helpful to draw that out real quick. So draw that out if that helps to like connect it a little bit, okay? If this problem is a little bit beyond you, don't worry. I want you to stretch your mind with it, but you will have different types of problems when we get to the quiz. Okay, so we have how long, let's see, the question altogether was, at most, how long can the team keep playing? We're talking from playing from the beginning. This is why it gets hard at the end here. So we have these 4 intervals when the players start to leave, but we were able to play for this first hour to start. So we played for an hour, then people started ditching out because they started getting tired. 5 minutes later, we had 14 players. Then we had, 11 players. Then we had 8 players, right? And it keeps going down. So I know that I could play for 1 hour and 20 minutes. 1 hour and 20 minutes. Before team is too small. All right. It's tricky. I know this one was tricky. Yeah, this one's real tricky. Are you glad it's not going to be on the quiz? Yes. Deer in headlights. Okay. All right, guys. We're going to do our best. We're going to do number 9. You'll see with the Kahoot that the scope is a little bit different. We're going to do number 9, then have a slight break. Oh, Maud's been waiting. I didn't see that. All right. Ahmad, sorry, I didn't see you in the waiting room. We are going over the homework problem 7, 8, 9 in the workbook, but I'm recording it so you can look on with us for number 9, and then I'll need you to check out the video I'll post later. It'll have these worked out. That you missed. All right, last one. We're going to do this so I have a little break because my brain is a little tired too. All right, here we go. The owners of a website have no more than 15,000 to give away for a contest. Okay, great. They have decided to give away 1,000 twice a day, every day until there's no more than 3,000 left to award as a grand prize. Okay, no more than 3,000. Okay, how many days will the contest run? Yeah, this one's hard too, but let's go ahead and do our process. Remember the process? If I read that and just try to get the equation, man, I'd have to switch gears and really, really, really focus. So let's not overwhelm ourselves. Let's make bullet points, do it one at a time. The owner of the website has no more than 15,000 to give away in the contest. Okay, so let's see. I'm just going to write that. I'm going to call that the budget, right? Because if your budget is 15,000, that means you could spend less than that, but you definitely have a max of 15,000. Okay. Now, they have decided to give away, they're going to give away 1,000 twice daily until there is no more than 3,000 left for a grand prize. So we'll say that no more than 3,000 left. Okay. Okay. How many days for the contest? I think we got everything. So the budget is 15,000. Give away 1,000 twice a day. No more than 3,000 left. So this 3,000 left, no more than 3,000 left, is our goal. Okay. I know that the budget here, I do call this budget, but really that is, you could call this too. I'm going to switch budget. I'm going to call this starting amount or dollars. Okay. I think it's a little better because then we can see we're going to be subtracting off things from that starting amount. All right, I'll give you a moment for that. I'm going to do a process right now that I think is going to be helpful because for this problem, I can do it. I could put this in, and remember that our goal goes on the right side. Okay, so I'm going to set up this. My goal is to have $3,000 at the end where I'll be able to give a grand prize from that. Okay, and this is going to be, the starting minus the giveaway, and it's daily, so we got to keep that in mind. Okay, so with this, let's look at what this one right here says. Okay, the goal, no more than $3,000 left. That's our goal, to have no more than $3,000 left. Okay, so what I'm going to have you do for these type problems, I want you to put 3,000 over here. Put a number that's bigger than 3,000. Any number bigger than 3,000, just put it here. It doesn't matter. 5,417. Then put a number that's less than 3,000. So let's put 100. Okay. Now let's read this statement again. The goal is to have no more than $3,000 left. Okay. What I like to do is think about instead of $3,000, I like to think about dogs. Okay. What if you owned a big old ranch and your mom says you can bring as many dogs as you want on this huge ranch, but you can have more than 3,000 dogs. You can have no more than 3,000 dogs. Jeez, it's a lot of dogs to take care of. It's a lot of brushing. You're going to be brushing every day for like 9 hours. Or you'll just have mangy dogs. It's fine. They'll be happy together. All right, so watch what I'm going to do. No more than 3,000 dogs. Okay, here's 3,000. Could I have 5,417 dogs? Would mom let me have 5,417? No, it's obvious, right? So if you use the example of dogs every time, it's like magic. It will make it make sense easier. Okay, so no more than 3,000 dogs. Could I have 5,417 dogs, Mom? Mom says, no, you can't. Can I have 100 dogs, Mom? Yeah, I can have 100 dogs. Would it be okay if I had 3,000 dogs exactly? Would that be okay? You can have no more than 3,000 dogs. Is it okay to have 3,000 dogs? Okay. Yeah. Okay. Both of those work, right? Both of those work, right? So what I have just done is I know that 3,000 works. Watch. 3,000 works. Could be equal. I know that a value less than would work as well. Less than symbol. Okay? It helps us to do the wording a little different if you just use an example like dogs, because you can imagine that, you get a limitation from your parent and you can only have 7 dogs, right? So, at most you can have 7 dogs. Could I have 10 dogs? No. We could see it quickly, right? So think about dogs. I don't know why dogs work so well, but we're gonna keep it, and maybe I'll do another example on this in a sec. But we did this. We got that down. We used our method here. All I did was take the number 3,000. I put a number larger. I put another number smaller, and I just asked the question: does this phrase make sense? For 5,417, no. For 100, yes. So I know it's equal then, or it could be a less than value because that works. All right. Woo! Starting amount. Starting amount 15,000. Okay, and that's done. We give away 1,000 twice a day. Okay, so how much do we give away every single day? If it's 1,000 twice a day, we're going to give out 2,000, right? 2,000. So watch. Minus $2,000 a day, which we'll call X. Okay. Just because it's about time when I want to do the break, I'm going to go ahead and subtract 15,000. See ya. And then we have line down the inequality. Looks like we're going to be dividing by a negative next. And that's keep the larger sign. Larger number is 15,000, so we keep the negative. There's more negative than positive. Find the difference between them because we have different signs. All right, last step. Last step. Right now, we have a less than or equal to symbol. Because we're going to divide by negative 2,000, though, something's going to change. It's going to end up being greater than or equal to. Remember that switch because we have the negative being divided or multiplied. We know we end up with a switch in the inequality. All right, negative divided by negative is positive. You can even cancel out zeros. Maybe you didn't know that. So we have 6. Ooh. So it's going to take at least 6 days to get rid of all of it. At least 6 days or less. Okay. So if you just put it in the chat, you think it's 6 days or less, it actually, maybe that's because we didn't switch that inequality. But we know that we need at least six days, maybe even more, in order to get to the point where we have no more than 3,000. Okay, why wouldn't it be less? Let me think about that. At least. No, that makes sense. Let's see. 1,200 at least. No more than, okay. So if we read this again, the goal is to have no more than $3,000, but it seems like we could have, we could end up with an amount that is less. So that's why it ends up being, it could be equal to or greater than 6. So you can just say your answer, at least 6 days. You can trust this. If you switch the equation, you set it up correctly, you set this up correctly, and you follow the rules, you can trust your answer, okay? This is really where we want to see if we did it right when we get to that equation, okay? There's some people that are asking, well, if some of my homework gives you the answers, then what's the point? The answers are never what we're doing. That's elementary school stuff. We're looking for the process. If you just said the answer for this problem without any of this, it's wrong. I don't even know how you'd get it. Okay, so this is partial credit I give on quizzes and tests. So if you had all this, you messed up the switch and you had the wrong answer here, you still get most of the credit because you missed one thing out of the 6 things we got to remember. Okay, so keep that in mind. I'm going to go and pause this video and actually I'm going to stop it because we're going to take a little break.